welcome all. So today we are back with another Leetcode challenge of June video. So we are today's our problem is insert delete get random O of 1. Okay, so design a data structure that supports all operations in average O(n) time, O1 time, sorry. So we are given some function that is insert, and we are given a value to insert an item into the value to the set if not already present. Okay, remove val removes an item value from the set if present, and get random returns a random element from the current set of elements. Each element must have the same probability of being returned. Okay, so this is basically we have to form a data structure that will support these three functions, that is insert, remove and get random, keeping in mind that we have to solve this problem or implement these three functions in O1 complexity time. Okay, constant time. Cool. So you can check the inputs and outputs for better understandings. So I am directly going to the solution. So what is the first data set that comes to your mind? You can solve it using linked list. Linked list can be your first choice, but hold on. If you choose linked list, then insert it can do in constant time operation. Get random also it will do it in constant time operation. But think about the remove part. Can it do it constant time? I hope you guessed it right. No. Linked list can't do it, because it can't be constant when it is not in the tail or head, that is it is in the middle. If it is in the head or tail, that it can be constant. Cool. So linked list is not our choice. Then what comes to your mind is hash set. Hash set insert can be done in O1. Okay, cool. Remove, yes, it can be done in constant time. Set remove function we will use. Then comes the number, that is a random number. That one will take linear time, O(n). So it is, I will rather not comment to use hash set personally. Then the third data structure that comes to our mind is array list. So array list insert, we all know that list.add it can be done in constant time. List.getNum it also be done in constant time, but remove it takes the linear time, that is list.remove. We have to scan the whole array to remove. So basically what can be the modifications done? So one modification that can be done is we can use both hash set and array list together. So how this can be done is we can actually do for the removal in the array list in order to make it constant time, that is swap the random index value to the last index of the list. So we remove the last index, that we can do it constant time. Okay, so this is the way we are basically going to solve this problem. Okay, we have to swap that random element to the last, then we can be deleted from the last. So then we have to then we can update the hash map, that is hash set, and the array list as well. So let's get started. Hope you understood. Let's define our data structure here. So first we are going to define our hash map. So here it goes. Sorry. hash map, take the integer value, both of this for integer, because one would be the value itself and one integer would be the index position. So it is like this. Then to keep track of this index value integer, we will use this array list, as I told earlier. Array list integer list. Cool and simple. We have defined our data structures here. Now we will create some objects of this hash map and array list by using constructors. A new keyword, map equal to new hash map. Now come to the creation of array list. New array list. Done. Object is created successfully. Then comes the insert part. Okay, so let us insert. So first we are taking k. I will explain why we are taking k. Just wait a minute, let me write it. Okay, so k would basically we are using for iterating over this array list and check if the value found is repeated or not. Okay, so if it is null, then no value found, then we will definitely add and return true. So okay, if k equal to null means no duplicates are found, then you can add happily in the list file like this. Okay, then we put the index in the map, just dot put val comma a list dot size -1. Basically list dot size -1 because you all know that indexing start from 0 in the arrays. Goal return true, else what have to return is false. Okay, so we are done with the insertion. Now we have to remove. This is the main part. We have to achieve the best time complexity, that is the constant time. Okay, so remove value, what I have told earlier, to swap the random position to the last position, and then remove will happen in the last position, and then we have to update the map and the list as well. So okay, so integer index equal to map.get as like earlier pretty much, map.get val. Then if index not equal to null, then we will assign the last index variable equal to list.size -1. Okay, then list.set index, we are taking the index, and list.get last index, we are taking the value, we are taking the value of last index here. Then Basically we have to swap now. Map dot put list dot list dot get index with index. Cool and simple. Now the value is basically at the last of our list. Now we can remove in constant time. Remove last index. Also update it. Update the map. Map dot remove the remove value. Cool. If this happens, then return true, else again return false. Okay, so now comes the random part. So we have to get the random value. So for that we have to initialize random equal to new random, create an object of random, then on index equal to random, it would take the random value in the next int, random dot next int till the list of the till the size of the list, done. Finally return the index and the position, return list dot get index. Okay, so I think we are pretty much done. So let's just check once if any bug or error occurs or not. Cool. Yeah, finished. Runtime. Let's see the runtime ones. Runtime code. Accepted. Awesome. Okay, so this was a good problem, and twist was this because we have to solve this in one time. This is the twist, nothing else. Otherwise, if it was not there, it was a simple problem. We can use function and get it irrespective of their time complexities. So this was a trick. We have to use two data structures for that swap, for the value hash map, and for the index to keep track we use the array list, and then basically the insert is easy. Then the main thing is comes in the remove part. We have to initialize a random variable to the last index, then the last index, when the value goes to the last index, then it is easy to remove from there as it takes the constant time. So this is basically the main part of the problem. So then we will update the list that we have to remove the value, and we have to update the array list also that we have to remove the position. Cool. And then comes the random part. We have to generate the random numbers on the list. So yeah, so this was today's problem, a pretty good one. So if you like this, give a thumbs up, and if you have any doubts, comment in the comment section. I will help you out. Other than so, subscribe my channel and stay tuned for the upcoming videos of June Leet Coding Challenge. Until then, stay tuned. Happy coding. Stay home and stay safe. Bye.